In 1996, a group of eminent astronomers, led by Alan Dressler, publicly suggested that NASA create a space telescope that could examine the skies in infrared light, a wavelength that enables scientists to see through dust and gas clouds and expands humanity's vision of the universe. The projected telescope would have a diameter of more than 4 meters and would operate in an orbit beyond the Moon. Its extraordinary powers would enable astronomers to peek much deeper into space and understand events that occurred further back in time, providing us with a much more comprehensive picture of the universe as we know it today. It was envisioned that this telescope will catch the sharpest images in history. Join us in this video as we take a deeper look at what the James Webb Telescope has been up to and how it could change everything. But before we get into it, let's go back to the roots of the James Webb Telescope itself, how it all started. After the first recommendation for the telescope in 1996, 3 teams of scientists and engineers from both public and commercial sectors convened to analyze NASA's feasibility in building the proposed telescope. All 3 teams decided that the telescope could actually be built, and in 1997, NASA agreed to fund additional studies to further define its technical and budgetary needs. By 2002, the agency had picked teams to develop the major instruments for the telescope, as well as an advisory board of astronomers to provide assistance for its construction. That same year, the telescope was formally christened the James Webb Space Telescope, in honor of NASA's former administrator, who made substantial contributions to the creation of the Apollo program. If you've made it this far into the video, you clearly share our passion for exploring the mysteries of the universe and uncovering the truths behind these groundbreaking discoveries. We dive deep into these topics regularly, bringing you the latest updates from space science, astronomy, and beyond. If that's something you're excited about too, make sure to hit that subscribe button and turn on notifications, so you never miss out on our upcoming videos. We've got so much more to explore together, and your support helps us keep bringing you content that makes the wonders of the universe more accessible. As construction on the Webb telescope began in 2004, engineers and astronomers confronted the task of establishing new technologies and methods to meet the rigorous scientific needs of the mission. Unlike Hubble, which could be repaired and upgraded by astronauts working from Earth, Webb would have to function at an unserviceable distance while yet meeting its various needs. Despite these hurdles, the crew successfully produced all 18 mirror segments and underwent extensive testing to verify they fulfilled the needed specs. Things were finally at a level where the ambition of sending the telescope into space and achieving its purpose seemed within grasp. Construction for the James Webb Space Telescope as a whole began in 2012 and proceeded through 2013, with separate sections of the telescope being constructed at various places across the globe. In 2013, development began on Webb's sun shield layers, which protect the telescope from excess heat and allow it to perform effectively in orbit. Over the next several years, Webb's many scientific instruments were subjected to rigorous tests of high temperature and vibration, and its 18 individual mirrors were painstakingly fitted into the telescope's backplane frame. In 2017, all of these components were merged together and tested at NASA's Johnson Space Center in Houston, Texas. In addition to being able to endure the effects of Hurricane Harvey without any complications, the telescope and its equipment also completed a final round of environmental testing in a huge thermal vacuum chamber to assure its correct functioning once deployed in orbit. Finally, on December 25, 2021, at 7:20 a.m. Eastern Standard Time, Webb was launched into orbit around Earth. So, how exactly does the telescope work? Space exploration is often oversimplified, and things can seem complex at first. The James Webb Telescope may seem like just another telescope, but it's unique in so many ways. This is why it took decades for it to get from conception to launch day. The James Webb Telescope is a powerful infrared telescope designed to observe celestial objects that are too cool or dim to be observed using regular telescopes. These objects include stars, nebulae, and planets in the early phases of their creation. Since these celestial entities radiate most of their heat as infrared radiation, the telescope is suited for capturing this sort of radiation, helping us to better understand these faraway objects. Infrared radiation is unable to travel through gas and dust, making it look opaque to the human eye. However, the Hubble telescope is able to see visible light, infrared radiation, and ultraviolet radiation, which allows it to scan objects hidden by gas and dust, providing us a sharper picture of distant processes in the cosmos. Additionally, infrared light can be utilized as a tool for investigating the qualities of objects on Earth, such as their chemical composition and temperature, which has many vital uses in astronomy, science, and technology. This radiation can help us better understand the structure and evolution of stars, galaxies, and other cosmic objects, or it can be used to identify symptoms of chemical contamination in our environment. To fulfill these goals, the telescope is equipped with a big mirror array, modern imaging and spectroscopy equipment, and state-of-the-art thermal control technologies that allow it to operate in severe conditions, as space is known for. This telescope is supposed to travel the vast space entirely on its own, thus it has to be created to handle anything out there without needing any aid. After its launch and separation from its vehicle, the telescope unfolded and began its trek to its destination, executing a complex deployment routine along the way. This procedure involved a lot of key steps, including crossing the Moon and dividing into distinct fragments. Once fully deployed, the telescope began operating as one of the most advanced instruments of its kind. Before we describe the discoveries this groundbreaking telescope has made, let's review the process it experienced to make it into orbit. The first crucial phase was, of course, the launch, followed by the solar array deployment. On day 3 of the expedition, remaining within the spaceship, 2 special pallets were deployed. These pallets carried Webb's critical sun shields, which are designed to keep the telescope cool and allow it to function correctly in orbit. The deployment of these shields played a vital role in assuring the telescope's operational success throughout its mission. On day 4, the tower housing the instrument package was moved to its final location and installed, a process involving intricate processes that proceeded perfectly. Next, there was the momentum flap deployment, when the sun's solar pressure on the enormous sun shield provided force to stabilize the telescope. Afterward came the sun shield membrane cover release, which exposed the tennis court-sized sun shields. This was followed by membrane tensioning, where the sun shield and mid-booms were deployed, and the sun shield was tensioned to separate its 5 layers. But the process didn't finish there. The James Webb Telescope had to go through several more critical milestones following its deployment in space. On day 10, the secondary mirror was deployed, along with the support structure to hold the smaller mirror in place. Then, on day 13, the primary mirror wings were extended, giving the telescope its full size and configuration. Once these steps were finished, the telescope was ready to begin its task of observing distant stars and planets. Now, let's talk about the real objective of the James Webb Telescope. One of the most remarkable characteristics of the telescope is that it wasn't created for a single purpose. Its aim is to reveal numerous riddles, therefore let's dive a little further. Telescopes like the James Webb Space Telescope allow scientists, like Daniel Einstein, an astrophysicist at the Harvard-Smithsonian Center for Astrophysics, to time travel by studying galaxies as they were in earlier stages of development. Light requires time to travel, thus the more away a galaxy is, the older it appears. With its extraordinary ability to see faraway galaxies, the James Webb Telescope can examine the early evolution of galaxies, helping scientists comprehend their genesis and growth. By comparing different galaxies at various phases of growth, scientists may piece together a more complete picture of galaxy creation over time. Webb's infrared capabilities make it suitable for seeing these distant galaxies, whose light has been stretched to infrared wavelengths by the expansion of the cosmos. Webb's capacity to detect these infrared emissions allows it to view further into space than other telescopes, capturing images of galaxy evolution across time. In addition to analyzing galaxies, the James Webb Telescope allows scientists to probe the creation of stars from the dense clouds of gas and dust known as stellar nurseries. These regions are so thick that visible light cannot penetrate them, yet infrared light can get through, providing astronomers a unique insight into these stellar birthplaces. With its expanded infrared capabilities, Webb will enable scientists to explore these regions in far greater depth than ever before. Marsha Recker, an infrared astronomer at the University of Arizona, notes that infrared light can travel through dust far better than shorter wavelengths like blue light, making Webb crucial for understanding star formation. Whereas Hubble could only examine stellar formation superficially, Webb will peek deeper into the dust, allowing a more thorough perspective of how stars are born and developed. Moreover, Webb is likely to reveal revolutionary insights into black holes. Black holes are invisible because they trap light, but their influence on neighboring stars and galaxies can be observed. Webb will be able to investigate black holes in greater detail by viewing the cooler gases and stars that whirl around them, providing scientists a fuller understanding of these fascinating objects. By obtaining data about black holes' temperatures, speeds, and chemical compositions, researchers can learn more about their mass, size, and how they interact with nearby stars and galaxies. This knowledge will help us better understand the underlying processes that drive the growth and evolution of galaxies throughout the universe. Another fascinating application of the James Webb Telescope is its potential to help us find life on other planets. Using infrared wavelengths, Webb can identify the chemical fingerprints of life in the atmosphere of exoplanets. These signals may include carbon dioxide, oxygen, and other molecules emitted by biological processes such as photosynthesis. Webb can identify water, methane, and other essential biological chemicals, which could indicate the presence of life. By evaluating these atmospheric variables, scientists can assess the habitability of distant planets in greater detail than ever before. Webb's capacity to investigate exoplanets in infrared light offers an unprecedented opportunity to explore these faraway worlds and assess whether they may house life. The James Webb Telescope has already started creating waves in the scientific community with its revolutionary discoveries. One of its significant breakthroughs has been detecting light directly from exoplanets. Previously, we could only deduce their existence based on their influence on surrounding stars. However, the telescope's ability to detect direct light from these faraway worlds allows scientists to examine them in unparalleled detail. Webb's identification of subtle infrared signals from these faraway objects provides us a closer look at the atmospheres, surface compositions, and potential evidence of life. Webb's contribution doesn't stop at studying distant galaxies, stars, and planets. It's also giving scientists new insights into our own solar system. For example, the telescope has allowed scientists to take a closer look at the frozen moons of Saturn and Jupiter, revealing hidden oceans beneath their surfaces. These oceans may hold the key to understanding the origins of life in our solar system. Additionally, Webb is helping scientists investigate distant objects in the Kuiper Belt, a region beyond Neptune rich with frozen comets and remains from the early days of the solar system. These observations are only a few instances of the wide-ranging capabilities of the James Webb Space Telescope. As the telescope continues its mission, its discoveries will transform our knowledge of the cosmos and our place within it.